Last time, I began to give you a snapshot of what it's like to be a visual ecologist studying tropical butterflies. In particular, I showed you the amazing phenomenon that is butterfly eyeshine, created by a secret reflecting mirror called a tapetum at the base of the eye, and that all seemed to go pretty smoothly. But oh no. Now, my main guinea pigs in that video were these guys, butterflies in the tribe Heliconini. But the main focus of my work centers around another tribe of Latin American butts called the Ithomini. I'm studying their eye physiology, anatomy, and neurobiology to understand how they are best suited to navigate their world. And today, I'm going to be showing you how I go about getting inside their heads. Quite literally. Now unfortunately, if you want to learn about butterfly eye anatomy, that does involve killing a few butterflies. So once I've done my eye physiology studies, I then have to chop the head off, unfortunately. And here in this fridge are my samples, and each one of these Eppendorf tubes is a single butterfly head preserved in ethanol. And what we do then is we stain these samples with this dark solution here. This is iodine, and this stains really effectively, which is why I'm wearing these gloves, to be honest with you, because I don't want to permanently stain myself with iodine solution. But what that does is it increases the contrast of the tissue, which is very useful when we eventually scan these samples under what's called a micro-CT. Now you may have heard of an MRI scanner before. A micro-CT works a little bit differently, but essentially it's producing the same sort of thing, only the micro-CT uses X-rays. And then that gives us really high resolution images for us to do all sorts of things, collect all sorts of interesting data about the eye anatomy and also neuroanatomy of these butterflies. Now, because of the potentially lethal X-rays it contains, I'm not actually allowed to show you the micro-CT room unsupervised, but just imagine a big scanning machine for now. But it doesn't matter, because I've actually already scanned all of these samples. All I need to do is take you to my office and I'll show you exactly what they look like. Right, so if I get one of these files up here. So this is an example of one of those micro-CT scans, and as I scroll through it with my mouse here, we're going through the butterfly head from the top or the anterior end all the way to the posterior end, the bottom part of the head. Absolutely fantastic. Each pixel in this image represents around 2 microns, which is 2/1000ths of a millimeter. So we're talking about super high resolution, and that's enabling us to see the different structures in the eye and the brain at exquisite levels of detail. So we can see here where the compound eye is, those individual facets, those light conducting units called ommatidia, which are directing light towards the main visual processing structures in the butterfly brains and what's called the optic lobe. But these micro-CT scans enable us to extract all sorts of interesting data about the eye anatomy and neuroanatomy of these butterflies, which will then enable us to compare between different species which live in different habitats, different light environments, and that will provide clues on how evolution has acted on the visual systems of these butterflies over relatively short evolutionary timescales. Well, how about that then? To be honest, I could scroll through these micro-CT scans all day. They're pretty mesmerizing to look at. But in the meantime, thank you so much for watching this video. I hope you enjoyed it. If you did, don't forget to hit the subscribe button to stay updated with all my wildlife and science adventures. You can also follow me on social media. The links are in the description below this video. In the meantime, thank you very much for watching, and I'll see you very soon.
Let's get scratching.